Angular momentum has a few useful definitions. The first is that it's the cross product of the radius of rotation and the momentum, just the linear momentum of the object. And the second is that it's going to be the rotational inertia times the rotational velocity. So these can be applied to problems depending on which is relevant. In the example problem of number 25 on the AP exam, we have two satellites of masses m1 and m2 orbiting a planet of mass m in circular orbits. The satellites travel in opposite directions with speed v1 and v2 as shown in the figure above. Their orbital radii are r1 and r2 respectively, and we are assuming that the mass of the central object is larger than the mass of than m2, and which is larger than m1. So this is a picture of what's going on, and as you can see, they're rotating in opposite directions. So for this question, we're trying to find the magnitude of the angular momentum of the satellite, of the two satellite system. So to find this, first we want to find the angular momentum of the individual satellites. So to do this, we're going to use the cross product of the radius of rotation and the momentum of the object. So for M1, this is going to be R1 times, or the cross product of R1, and the momentum is equal to the mass times velocity, and we know both of those, so cross product of that and m1 times v1, and this is our first angular momentum. So we have this. And because these two vectors are just going to be perpendicular to each other, we don't need to consider that cross product, and we can just take the magnitude of the two vectors and multiply it, and that'll make our life a lot easier. So that'll just be R1 M1 V1. So that's our first one that we need, our first angular momentum. And for the second one, it's going to be the exact same thing, only obviously with R2, M2, and V, and V2. So what about the whole system? To do this, we have to combine these two angular momentums together. However, they're rotating in different directions, which complicates things a bit, meaning we'll have to subtract one from another rather than adding them together. So the magnitude of the angular momentum would be the magnitude of m1 v1 r1 minus m2 v2 r2, because we just combine them both, subtracting instead of adding because they are rotating in opposite directions, just like that. That bottom expression is that last angular momentum that we're looking for. And this is option D on the AP exam, question 25.